Hi, 7th grade. We are in lesson 4, session 4, last one of the lesson. So we are going to talk about proportional relationships and just kind of go through and make sure you understand everything. Let's look at the example. A straight line passes through the points 0, 0, and 1, 3/4. What is an equation that could represent this relationship? Okay, first of all, I know that it's going to be a proportional relationship because it goes through 0, 0. That's good news. However, if I'm given just 1 point, can I find the slope? Sure, why not? Remember, slope is just when you take your y's and you divide it by your x's. What's my y here? 3/4. What's my x? 1. What's 3/4 divided by 1? 3/4. So my slope is 3/4, right? Slope is the constant of proportionality. And it's asking me, can I make an equation? Yes. Y equals slope times x. Ta-da! How did we do that? Well, first we took the one coordinate they gave us. We took the y divided by the x and got our slope. Slope is constant of proportionality. Then I remembered my special equation, y equals mx plus b, but I don't have to deal with b right now, so it's just y equals mx. M is slope. I know the slope, so I put that in for m, and ta-da! That's how I got it. Number 1. Ju Long is making punch. For every 3 cups of juice, he needs 6 cups of seltzer. Graph this relationship. Is there a proportional relationship between the cups of juice and the cups of seltzer? Okay, let's put cups down here of juice. And then let's put cups of seltzer over here. Is there anybody who even likes seltzer like by itself? Because I sure don't. That's disgusting. I really don't like carbonation. I'm going to make this easy, and I'm going to make my graph just go up by ones, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, for every 3 cups of juice, it's going to be 6 cups of seltzer. So let's go over 3 for juice, and then up 6 for seltzer. Bam. Now we always start at the origin. Draw me a nice little line. Okay. So will this be a proportional relationship? Yeah, because now, do I know my slope? My slope goes up 6 over 3, which is the same thing as 2. Wouldn't you guys agree? 6 divided by 3 is 2. So that means my slope is 2, which now means I can put it into my equation like that. Now can I go find how much any cups of juice will be? Well, for example, what if I want to find out this guy? If I put a 1 in right here, 1 times 2 is 2. Shouldn't it land where 1, 2? Yes! So is this a proportional relationship? Yes. How do you know? It goes through the origin. It's a straight line. And I found the slope. Of 2. Okay, so that's got all the reasons why it works. Hooray! Number 2. A potter buys clay by the weight. The graph shows the relationship between the weight and the cost of the clay. Okay, so based on this graph, I don't have very many crosshairs. It looks like the only crosshair I really can see is this one. You gotta be super careful. This looks like a crosshair, but it's not. This looks like a crosshair, but it's not. Okay, you gotta be super careful. So the only thing I know so far is that I can buy 8 pounds of clay, and it's gonna cost me $20. Do you see that? Okay. So for every 8 pounds, it's $20. Can I take my y's and divide my x's? Let's try it. 20 divided by 8. 20 divided by 8 is not going to go completely nicely, but I can reduce that. I'm going to divide these each by 2. No, 4. Yes, 4. That gives me 5 halves. Guys, I just found my slope. And I haven't even read the question. Okay. Is there a proportional relationship between the weight and the cost of clay? Well, yes. How do I know? It goes through the origin. It goes through the origin. It is a straight line. And I found the slope. The slope is 5 halves. Ta-da! What does the point 5, 12.5 mean in this situation? Well, guys, this is my x and this is my y. My x is my weight of pounds. My y is my cost. So that means for every 5 pounds of clay, it will cost $12.50. Okay? Number 3 says the graph shows the height of a plant after D days. Which equation can you use to represent the situation? Okay, so the H is my Y's, the D's are my X's. Let's go find the slope. Go find the crosshairs. Aha, here's a crosshair. It looks like it's over 6. Oh, sorry, rise over run. Rise over run. 4 over 6. Because you go up 4 over 6. Okay, 4/6 can be reduced to 2/3. I found my slope. Now let's put that into an equation. Y equals 2/3 x. Now in this case, we're going to be using h's and d's. So where every time I see a y, I'm going to put an h, and every time I see an x, I'm going to put a d. So it's actually h equals 2/3 d. Now can I go find my answer? Yep, and it looks like it is D. H equals 2/3 D. Now, Umi chose C. How do you think she got that answer? Do you think maybe instead of rise over run, she went run over rise? Because if you went run over rise, you'd get 3 up 2, right? Instead of up 2 over 3. So I think she did run over rise, not rise over run. And that would get you the equation 3 over 2, which is wrong. Don't do what Umi did. Okay, number 4. The graph shows the relationship between distance Amelia can drive her car and the amount of gas she needs. How much gas will Amelia need for a trip of 125 miles? Show your work. Okay, let's go find the slope. Go find me some crosshairs. Ooh, I found a crosshair. And we can always say 0, 0 is a crosshair. So it looks like we're going to be going up. You know what I want to kind of test for a second? You know how each of these are worth 5? And so I could say I'm going up 5, 10, 15, 20, 25. And then over 1. I wonder if I could also say 1, 2, 3, 4, 5 over 2. It's interesting. Or do you have to go by the scale? Let's go by the scale just to be safe because we don't want to make any mistakes. I was just kind of getting adventurous there for a little bit. Okay, so what is the slope? The slope is up 25, so that's our rise. And then it runs 1 over because the scale is going up by halves. So it's 25. So knowing now that I know my slope, I can now put that into my equation, y equals 25 times x. So now let's go see how much gas, which is x's, will she need for 125 miles, which is y's. So I know my y's is going to be 125. So what I need to do is I need to go solve x. How do I get x all by itself? Well, I have to do the opposite of what's happening right now to x. Right now, it's being multiplied by 25. What's the opposite of being multiplied by 25? Being divided by 25. If I divide the whole thing by 25, that's going to get rid of 25, and that'll give me x all alone, which is what I want. But if I have to do it to one side, I have to do it to the other, okay? So now I have 125 divided by 25, which is easy, that's 5. So 125 divided by 25 equals 5, and then all I have left over here is an x. Hey, we did it. How much gas will Amelia need for a trip of 125 miles? She will need 5 gallons. Now let's talk about how we found that. First, we found the slope. Did our rise over our run. We found the slope was this. Then we put the slope into our handy-dandy equation. And then it told us we know she is going to go 125 miles. Oops, sorry guys. We know she's going 125 miles. Miles is our y. So we're going to put 125 in for y. Now we just had to go solve for x. Okay? Number 5. Each line represents a proportional relationship. Would you agree with that statement? I do, because they're both straight lines and they're both going through the origin. Can you guys write an equation for each of these lines? Ooh, yes we can, yes we can. Okay, let's just focus on A first, because that's, first in the alphabet. Go find me some crosshairs. Okay, found some crosshairs. Now go find me a slope. The slope is up 1 over 2. Up 1 over 2. Up 1 over 2. So now I found the slope. Now let's go put that in our equation. Ta-da! So we found the equation for A. A is y equals 1/2 x. Now let's go find our equation for B. Go find me the crosshairs. Okay, B is up 2 over 1. Up 2 over 1. Up 2 over 1. So my slope for B is 2, so now just put it in an equation. Ha ha ha! Y equals 2x. Hooray, we did it! Once you find slope, it's super easy. Then you just pop it in to the equation, y equals mx plus b. But we don't really deal with the b right now, so it's just that. All right, I think this is the last one. I'm wrong, it's not. Okay, number 6. Look at the lines. Tell whether each statement is true or false. Line A shows a proportional relationship. Yes, because it goes through the origin and it's a straight line. Line B shows a proportional relationship. No, because it does not go through the origin, but it is a straight line, but it has to go through the origin. C. A constant of proportionality for line A is 2. Now remember, constant of proportionality means the same thing as what? Slope. Could I say the slope of line A is 2? That would mean it would be going up 2 over 1. Let's go see. Up 2 over 1. Up 2 over 1. Whoa. Whoa, whoa, whoa. Up 2 over 1. Up 2 over 1. Up 2 over 1. Oh my gosh, you guys. Does my blue line do that? Heck no. So my correct answer is no, it's not. What is the slope of A? The slope of A is up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So slope is 1. Neither line includes a point that could represent the ratio 4, 3. 4, 3 is the same thing as, like, I don't know, 3, 4. Let's go see. Over 3, up 4. Hey, something lands on there. What about over 4, up 3? No. Neither line includes a point 4, 3. Remember, 4, 3, guys, the reason why I switched their places is because this is our y, this is our x. This is our x, this is our y. So that's why I switched their places, okay? But this isn't true because 3, 4 lands perfectly on B. So this is false. All right, next page. Number 7. The relationship for a proportional relationship, the equation for a proportional relationship is y equals 5.8x. Psst, that means 5.8 is the slope. The graph of the relationship passes through the point 1, 5.8, which represents the slope. But what's the big word we've been using to mean slope? The two big words we've been using to mean slope is constant of proportionality. Mindy says that the equation P equals 1.5Q and 2/3 P equals Q both represent the same proportional relationship. Vivian says that cannot be true because the constant proportionalities are different. Which student do you agree with? Okay, are these different equations? Let's go find out. She's saying P equals 1.5Q. Pretend that's our y and that's our x. And then this other girl is saying, I'm just going to rewrite this a little backwards. I'm going to say Q equals 2/3 P. Now, you guys, isn't this the same as this? It's just I switched their places. Yeah, it is. So, why do you think one girl is saying it's the same? It's kind of interesting, isn't it? I'm going to replace, here's what I'm going to do. I'm going to be kind of a little stinker. I'm going to replace P's for Y's and Q's for X's because that's what we're used to working with. So let me erase and let me play around for a second. I'm going to rewrite this equation, but without P's and Q's. I'm going to say y equals 1/2 Q. Oh, sorry, not Q, X. And then I'm going to rewrite this equation, and I'm going to say 2/3 y equals X. Okay. This equation over here, this looks like something that we're used to. Why is this one not looking like something we're used to? It's because the y's and the x's look like they're in the wrong spots, right? We're so used to y being the guy all alone on that side of the equation. But, thanks to algebra, we can make y be the guy all alone in the equation, right? Can I change this equation so that y is the guy all alone? How do I get y all alone? I do the opposite of what's happening to it, right? And what is happening to it? Y is being multiplied by 2/3. What's the opposite of getting multiplied by 2/3? Well, it's when you divide by 2/3, and when you divide by 2/3, you just multiply by the reciprocal. The reciprocal means you flip it. Wouldn't that get rid of these completely? Which means I have to go do it to the other side, right? Now I've changed this equation. Now this equation is y equals 3/2 x. Now hold up. Isn't 3/2 the same as 1.5? Yeah. Are these equations technically the exact same equation? It's just that we had to put this answer over here so that y got to be all alone? Yeah. So Vivian is actually wrong and Mindy is correct. So who do we agree with? We agree with Mindy because both equations are actually the same. We just needed to solve for y. Okay, because we solved for y on this one, we were able to make both equations the same. I'm really hoping that, see, this is me from the past talking to you to the future. Right now it is September 7th, and I have no clue when you're going to watch this video. You'll probably watch this video towards the end of September, so I'm talking to you from the past here. But I'm really hoping that in the next few weeks we can do a lot of algebra problems together so that this makes sense to you. Right now, on September 7th, this would not make sense to a lot of you. So I'm hoping that between now and whenever you guys actually watch this video, this will make sense and how to solve equations. Okay? All right, last one. Hallelujah. Number 9. Graph a proportional relationship and then write an equation that represents the proportional relationship. Oh my gosh. Okay, you guys, I don't know about you, but I'm so sick of doing math right now. I'm going to make the easiest proportional relationship you've ever seen. Okay, is this a proportional relationship? Yes. It goes through the origin. It's a straight line. What is the slope? The slope is up 1 over 1, up 1 over 1, up 1 over 1. Slope is 1, and now let's go find an equation. An equation would be y equals 1x. Super, super easy. It's just because I really don't want to spend any more time doing this. All right, guys, so that is the end of the whole lesson 4, which means we will do a review of the lesson, all the lessons, and then we'll take a quiz. All right, bye, guys.